This is a version of the SMAX booster. Well, I guess it's time to introduce you to my 1993 Jeep Grand Cherokee with 306,000 miles on it. That's more or less the only vehicle I have, and I decided to use it as an experimental car for the hydrogen electrolyzer. See, I'll take a look here. The plans that you can find on the internet, you can see the plates. So what you see is the stainless steel plates that I picked up at Lowe's. Very inexpensive. Ordered the rest of the parts for that from McMaster Car through the mail. Now you can see the bubbler, check valve, a small amount of water in the tube. The tube comes back around and enters the air intake, the air cleaner. You can see I created some clips and straps to hold it in place on a platform in a convenient spot in the engine compartment. Underneath I have my fusible link. I don't want to run more than 20 amps. I'm running it off of a stock alternator, which puts out about 90 amps. And one of the things about a lot of these internet plans is they're telling you to ramp them up to 30 plus amps to generate the HHO, and that's a bad thing. You're going to be cooking a $300 alternator if you're not careful. So you can see I have a control contact here, and then the wires go down, and I don't know if you can see it from here. There is a continuous contact solenoid down there. So once I flip the switch in the driver's compartment, the contact's right here. That in turn energizes the terminals that go into the SMAX booster and generates the hydrogen. Now, the one thing about this is I created the first one after many hours thinking about it, and what happened was I ran it about 150 miles and it melted. The heat generated by this thing it just accumulates, it keeps going. So I installed a high limit switch, 55 degrees Celsius here, that will shut the booster off. Then I also have a 50 degrees Celsius contact here that operates a pump that's mounted on the firewall back here. That pump in turn circulates the electrolyte through the booster. When it heats up, the pump kicks on, circulates it through a series of hoses into a cooling coil that you can see that I've put behind the grill here. Okay, and that's just in there. I try to make it as neat as possible. And there's a reservoir under the car that I bolted here. You can see that piece of 2-inch PVC pipe holds the volume equal volume of the electrolyzer, and that is so that when the pump kicks on, I have an ample amount of cool electrolyte that'll pump in there and exchange it, cool it down, shut off the pump switch, which in turn shuts off the pump, and I'm back to square one. Now if that fails, if I'm on an extended trip, it'll continue heating. That switch will shut the electrolyzer off. This switch will keep going, keeping the pump going, so I'll be cooling as I go. Haven't experienced that yet, so I think that it's probably just fine with the cooling system that I've got. It doesn't run all the time. All these controls are very important. You can buy those kits on the internet. You can throw them in your car and think, woohoo, I'm creating hydrogen. It's an accident waiting to happen. It's going to cost you. You're going to fry your alternator. You're going to cook wires. You're going to short something out. It might work for a little while and look really cool. I love those guys on the internet that throw like spoons in a vat of lye water and make bubbles, and they're like, yeah man, we're making hydrogen. Well, we need something practical. So we've got millions. One of the things is we've got millions of vehicles out there like this that people use for commuting every day. Okay? We need to retrofit them. You can't create a 100% powered hydrogen engine. It'll rust, it'll corrode. We're using a technology that's not meant for it. Speaking of technology, I'm going to show you the odometer real quick. See that? 307. And then in here, what I have is I put the EFIE. I just encapsulated it in a little unit and velcroed it to the dash. Now, in order to adjust that, in my glove box, I just bought a cheap voltmeter. I soldered in a couple of leads. So when I adjust that, I just adjust it and let it go. That's it. I take that off. Doesn't affect it any. All I've got is a little black box on there. I tuck the wires back out of the way so it, you know, it's not obtrusive at all. You can see I have two LEDs. One LED tells me that the electrolyzer is working and that the EFIE is in fact functioning. The second light below that is for the cooling pump. Now at times, if it gets warm, the cooling pump LED will come on and the LED for the electrolyzer and the EFIE will go off. That tells me I'm over temperature and the cooling pump is cooling. And if I want to stop the system, go back to normal gasoline, I just shut the whole thing off. But we don't want to do that right now. So I'm going to fire this thing up, let you watch it. It's a good system, it's a reliable system. It's not one of these deals where you're going to create some bubbles and oh, everybody's going to say wahoo, and then it's going to cook, it's going to fry, it's not going to work after a couple miles down the road. You're going to ruin your engine. You'll get electrolyte bubbling into there. It'll get hot enough so that it'll boil instead of electrolyzing and creating gas. One of the things, this is the temperature of that electrolyte varies the output greatly, and also the amp load. And I've got this dialed in with the pump running and the electrolyzer on at about 18 amps. As it gets warmer, that amperage will go up, and I've calculated it so that at 120 degrees or so, I'm going to be right at my 20. Two things could happen. My fusible link could blow, which will cool the system down, or my high limit temperature sensor will kick it off, and or the pump will come on and cool it down. Either or. You have to have these safety features on here, or it's not a reliable system. It'll work, it's not going to work long term. You don't want to have to keep messing with it. You want something that's going to run you back and forth to work every day. So that's what a guy does with his spare time.